How would we represent the graphical meaning of V average total, which is negative 13.91? Could we do that? Negative 13.9, 90. We could also represent that there as the slope of the secant line. This line, you can connect the line from the beginning to the end. That's called the secant line. You learned that in calculus. That connects any 2 points of a graph. And the slope of that line is the V average total. So any 2 points of that. And does it make sense? Are the numbers making sense? The V average total is what? Negative 13. Is the slope of this line negative? Yes. And is it negative 13? Does the number make sense? Negative 13? In terms of this one was negative 180, right? And this one is negative 13.9. That makes sense because this is much less negative. It's much less steep. This is much more steep. So your graph should bear that out as well. You know. In other words, if you had a graph like this, let's say you did it wrong and you did something like this. Okay? This would be wrong because the slope of this would be positive. Slope of that would be negative. Slope of that would be positive. Well, that doesn't make sense over there. It's negative. You see? This would also be wrong. What's wrong with this? Yeah, you got it. The first velocity is too steep. The slope of this is so steep. The slope of this is not as steep. That doesn't match with your numbers. Positive 70, negative 180, no way, you know. So this needs to be steeper. This needs to be more shallow, you know. This one makes sense. That's the V total is okay, but this one, the first two are not good. Okay? So when you're graphing these, make sure you graph them nice, practice them, and then you can practice the review sheet problem. Look at some of the other examples I have on the notes. Okay, now let's do the V versus T graph and the S versus T graph. So we could do right here. This is and then the A versus T. Okay, V versus T is the velocity graph. Well, the initial velocity of the car we're assuming is positive 70. The car is initially moving already. And then by the time, okay, let's see here. 1, 2, 3. So by the time it reaches 5/7 of an hour, it goes, the velocity goes to like 0, kind of steep here. Then it stops for 1 hour, right here. Then what's the velocity? Negative 180, right? So on the chart, that would go twice this, 2 times, way down here somewhere. Negative 180. And then stops right there. I mean, that time period is very short. Now the S versus T graph is the speed graph. The only thing different is it's the absolute value of this graph. So we could just quickly do this. 70 goes down, goes 1 hour, then goes up twice, a little more than twice. So positive 180. Okay, now, see, the only thing was positive, 0, and then back to positive again, the speed. The speed is always positive. Okay? Now I can represent the average V on this. In other words, the average V that we got here, which was positive 70, I can represent that on the V versus T graph as itself. The average V. Now, when something is going at a constant velocity, its average is itself. Okay? In other words, if you keep getting B's on a test, what's your average? B. And each individual test is a B, you know. So your average is the same as your instantaneous value then. So you see, it's itself. V average 2 is this one, is itself. And then V average total, which is negative 13. Now, what would that be? You have to visualize this as almost, imagine looking at a topography. Like, let's say this is a little hill. This is sea level. And then this is down on the below the sea level. So if you look at this topography, what's the average height of that topography? Well, the depth of the sea level is more than the height of that little hill. And then you got the sea. So the sea brings it down. Just between the sea and the hill, the average would have been here, right? But the bottom of the sea level brings it down more, so the average height is going to be down, negative. So that's going to be V average total. Which is negative 13. So in other words, your numbers that you got should make sense as on the graphs. Okay. The other thing you can show here, you can show the A average. Okay, because A is the derivative of the V, right? So what was the A average one? Negative. I had it here somewhere. Negative 98. That one is going to be the derivative of the secant line connecting these 2 points. So if you connect those 2 points from here to here with a secant line, A average 1 is the slope of that secant line. And definitely looks like it's negative, you see. And then A average 2 is the slope of the secant line connecting these two. So you connect from here to here. Negative 405, I think it was. And again, it makes sense. You see, it looks steep. And then from the beginning to the end, the secant line connecting that one is going to look like this. Let's see here. Okay, here is what I got to be careful for. What was A average total? Negative 115, right? It shows over there, negative 115. Is it more steep than A average 1? Is it? Now, the way that I've drawn, it looks less steep, so I drew it wrong.